Okay, so in this particular problem, we're going to look at acceleration. Acceleration is the change in the velocity of an object divided by the amount of time in which that change in velocity is occurring, okay? So imagine something's moving at some speed and then it starts going faster or slower. Its velocity will change. The delta symbol here, this is called delta, refers to change. You can just call that change in. Okay, change in velocity divided by change in time. Okay, notice that it's similar to the formula that we had for velocity, right, or speed, which was the displacement divided by the time. Now we're taking really the velocity change itself, the speed change divided by the change in time. Now, for most problems, they're going to tell you how long the time is. So it usually delta t for these problems is just t. We just call it time. Okay. So in this case, time is 20 seconds. Notice there's two speeds, right? So it's changing speed. So let's do delta as the final velocity, v2, minus the initial v1. We're going to use these little subscripts 2 and 1 to refer to final and initial. Okay. And then again, as I said, t would be down here. Okay. So what is the acceleration telling us? It's telling us how much our speed is changing, how fast our speed is changing, the rate of the change of speed. If our speed changes very slowly, like we go 15 meters per second, and then another hour later, we're doing 16 meters per second, another hour, we're doing 17 meters per second. That's a very slow change in the speed, right? The rate of change of the speed is very little. On the other hand, if we go from 15 to 25 meters per second in just a couple seconds, that's a very fast acceleration, okay? So it says here, find its acceleration. So we just need to know the difference in velocity, the two speeds, and we need to use and know the time. And we have that all, right? So I'm going to put in, here's a little picture. Okay, so here's your car. So it's initially moving. It's not like it's not moving. It's moving at 15 meters per second, which they say in there is about 34 miles an hour. That's enough to get you a speeding ticket in Brooklyn, right? So you're moving at 15 meters per second, and then you push the accelerator, right? It's fun stuff. You push that accelerator, and you start going faster and faster until finally this car is now really kind of going kind of like highway speed, right? Now it's going 56 miles per hour, okay? Which is 25 meters per second. Okay, notice we're going to use in this chapter meters per second as the typical speed, and we're going to avoid using miles per hour, even though that's used in the United States on roads. Okay, so v2 minus v1. So this is v2, right? Because that's where we, our final, that's our final speed, 25 meters per second, and we used 15 at the beginning. That's how fast we were traveling at the beginning, 15 meters per second. Divide that by 20 seconds, and you get 10 over 20, right? 10 meters per second over 20 seconds. Well, that's a half, right? 0.5. We generally want to avoid putting a half or 2/4, so 3/6. We generally want a decimal number or scientific notation. So 0.5 or 0.50 meters per second, but it's per second divided by seconds. It's kind of interesting, right? Meters per second divided by seconds. Well, this is equal to meters per second squared. It's per second sometimes is how people will write it, or they used to anyways. So there you go. Our acceleration is 0.50 meters per second squared. The larger the acceleration, the bigger that value right here, the bigger that is, the more rapidly your speed is changing. So if I do 0.5 meters per second squared and then change my acceleration to 1 meters per second squared, I'm doubling the acceleration. You're going to feel that more, right? You feel the acceleration. Okay, so there you go.